So, for instance, well, what do you think this thing is right here? A comet, yeah. Now, actually, I'll tell on myself, I used to think comets are kind of like jet trails. We call contrail jet trails, you know. But comets are not like that. Comets, because they're a fair piece away, actually don't move across much of the sky in a given day. Okay, so you'll see the streak here, then you'll see the streak here the next night, here the next night, here the next night. So there are maps out there to kind of tell you where the comet is, and it doesn't move a lot. Okay, so yeah, that's a comet. The comet tail, and this is, we'll talk more about kind of things about the comet. So here's, now, so that was a picture of a comet, right? Now, this video I think did a pretty good job talking about comets and asteroids. Okay, what do you think is the biggest difference? Like, what does a comet have that asteroids don't? Ice. Yeah, they have ice. So like in here, if the sun's here, and I wear my solar system shoes again, okay, so if the sun's here, we have the terrestrial planets, here's the asteroid belt, and here are the Jovian planets, and then out here we have the Kuiper belt and the Oort cloud, right? So here's where your icy stuff usually is. Although the video said that here, actually in the asteroid belt, and there are asteroids more than just in the asteroid belt between Mars and Jupiter, but sometimes some of those could actually be masquerading comets. I think that's kind of neat. All right, so let's see. Ceres, we spell it C-E-R-E-S, actually is between Mars and Jupiter. So Ceres is one of those. It's a dwarf planet. Who else is a dwarf planet? Pluto, yeah. So Ceres in the asteroid belt and Pluto out there beyond Neptune are both dwarf planets. These are some kind of pretty pictures. Don't these kind of remind you of the moon? Kind of these moon things? Yeah. Kind of that grayish sort of thing. We call it, on the moon we call it regolith. It's kind of like powdered stuff. Let's see, so an asteroid. All right. So this thing that says basically if you were to take all of this crumbly stuff between Mars and Jupiter, the stuff in the asteroid belt, combine it together, I think the video kind of alluded to it, it's like a failed planet. It's not really very much stuff there, okay? It wouldn't combine to be enough to be generally a planet, okay? So all of this, it's not really necessarily a failed planet. The other thing I didn't like about the video, it's a common misconception that if you are in the asteroid belt here, that your asteroids are all kind of floating. They're orbiting the sun, okay, just like the planets orbit the sun. But there's a misconception that they're close together. They are really far apart. Okay, it's like you have to dodge them. No. They're really pretty far apart. This right here is showing you actually an image of kind of a trail of an asteroid. Now, I haven't really done much with trying to find asteroids in the telescope. The way you see asteroids is the same way you see a planet. Basically, light reflects, hits the asteroid, and it comes back to you. So it's actually going to be moving in the sky. So that's a trail of an asteroid. All right. So there are 3 places I want you to know where there are asteroids. And the asteroid belt, when anyone says, where's the asteroids? Well, an asteroid belt, right? Between Mars and Jupiter. There's 2 other places I want you to know about 2 different types of asteroids. 2 other types of asteroids. These are called Trojan asteroids. And the planet that most notably has them is Jupiter. So I'll go over here where Jupiter is, okay? Now, other planets have Trojan asteroids. What they are kind of these geometrically, like, stable places we call Lagrange places in front of Jupiter and behind Jupiter, and basically they escort Jupiter as Jupiter orbits the sun. Those are Trojan asteroids. Are those going to run, does those seem like they run into Jupiter? No.
Do they orbit Jupiter?
They don't orbit Jupiter, they orbit the sun.
So they're just kind of stuck there.
They're stuck there, yep. Yep. Yeah, they're stuck in Jupiter's orbit. Yeah.
So they're like in synchronous rotation?
Yes, they are in synchronous orbit, kind of. Yep, exactly. And the Earth actually has, as I understand it, the Earth is being escorted by Trojan asteroids too. Okay, so it's not just Jupiter that has these. And the reason it's like a geometry thing, these are actually physics would say these are like Lagrange stable places. There's a reason for those. It's not just random. Although if you're an alien, that's where you would hide. Okay.
So would those be like the smartest to mine? Could
Yeah.
you mine those?
I don't know, would those be the ones you
They're
mind?
always there.
Seems like you know where they're gonna be, yeah. And you go out and you'll entrepreneurs. So that's the second of three. The next one, or the last one, okay, are called Apollo asteroids. I don't know why they call them Apollo asteroids, Apollo mission. I'm sure like Apollo was a Greek god, right? Okay. Okay, and I don't, was he a good god or bad god?
Yeah, I think he was a good guy. I think,
Good guy.
yeah, if I remember correctly,
He's the one that takes the sun across the sky, doesn't he?
yes.
Oh,
He's
so
like
he's
the
a
god
good
of
god, he
music.
takes Apollo takes the sun across the sky. I'm
On
liking
his
that.
Chariot.
On his chariot. Very good. So Apollo asteroids. Now these are the wild children. I call them wild childs. Okay. So Apollo asteroids, and you heard the video talk about how, I'll go over to Jupiter, how Jupiter actually can kind of nudge an asteroid, an asteroid belt, yeah, nudge it and kind of send it out of there. And at that point, it becomes an Apollo asteroid. Okay, so they're wild children. They aren't here in the asteroid belt, and they aren't at stable Lagrange places called Trojan asteroids, okay? So Apollo asteroids are the wild children, and those are the ones that could guess. Okay? They cross Earth's orbit. Those are the three. And then these last kind of bit, these last three, right here and kind of this right here, talks about those asteroid belt asteroids. Does that sound redundant? Sometimes we call these belt asteroids, the ones between Mars and Jupiter. And actually they kind of come in clusters, and that's kind of what this graph down here is showing you. Okay, these like little kind of clusters, and that's related to the gravitational kind of setup of Jupiter. What?
Not one just falls, multiple fall at once?
Right, they don't fall, but they're kind of clustered together as they orbit the sun. Now, all of these belt asteroids, or asteroids in the asteroid belt, they orbit the sun too. So they're all kind of, and they don't necessarily collide on a regular basis. There's a lot of space between them, but they're kind of clustered. Yeah. All right. So there's, now which one to be one of these little kids? Touching, okay. Now, I sometimes get this wrong. Ugh, it drives me nuts. But, okay, so this is my Earth. This is, what's that?
Atmosphere.
Atmosphere, thank you. The Earth's atmosphere, very good. Okay. So, I'll put space rock out here. So space rock is equal to meteoroid. Meteoroid. Okay. Now, next to meteoroid, I'm going to actually put the term asteroid. They both have the oid thing going on for them. The difference between a meteoroid and an asteroid is size. Asteroids are larger. They're both rocky. They don't necessarily have the icy component that comets have, okay, but it's a space rock, okay? Meteoroid. Now, in the video, we definitely saw some were animated and some were actually, like somebody took a picture or a video of this. Check this out. Okay, here's my rock. This is a meteoroid because you guys told me this is Earth's atmosphere. This is Earth's surface. Okay, this right here, this is my space rock. As it falls through the Earth's atmosphere, what happens?
It starts burning.
It starts what?
Burning.
It starts burning, it starts fizzing, it reacts, it heats up actually the Earth's atmosphere. I'll take burning, it kind of disintegrates and creates a lot of heat. Okay, and actually excites this, what does N2 stand for? Nitrogen, yeah. It excites the nitrogen and O2 in our gas particles in the Earth's atmosphere, and it makes that pretty streak. Okay, so this pretty streak actually is what we call a meteor. See, too many, okay, a meteor, okay? Meteor, have you ever heard of meteor showers? Okay, so a meteor actually is a short event, okay, it's that streak.
Could like a meteor made of a special compound, could it, as it enters the atmosphere, make a new compound with the into?
Are new things formed as it reacts? I hadn't thought about that much. Actually, I think I have this right. I don't know. I know that like ozone is formed by lightning, like with the heat from lightning. Like it takes O2 and it forms O3, and that's kind of what you smell sometimes with, like if you have electrical, that's ozone. But I don't know, I have to think about that. What I thought you were gonna say is what if, like you have something that's an alien and what would that happen? You see where my mind is, the whole alien thing. I don't know. But one more thing, all right? These people, these kids up here, okay, I'm gonna make a rock down here, okay, and I'm gonna call that, I've got too many arrows. I'm gonna call that a meteorite. Meteorite. I'm gonna say you can touch it. Touch it. Meteor streak, short, and of course up here I said that was a space rock. So we have those three meteor thingies. Meteoroid, meteorite. Pick it up. Actually, I wore this today. I wore this today. I got from my aunt, and let's kind of turn around. But anyway, in there it's like got some. In there is a space rock. It's like, I know, isn't that cool? Yeah, the whole thing isn't a space rock, but if you look real closely, there's like little dark flecks in there. Wasn't that sweet of her? Mm-hmm. Yeah. And this is where I say, you're like, well, how did they know that was a space rock? Well, that's where you need to go and understand more about what identifies Earth's rocks versus space rocks. It's a chemical composition thing. Did you have a question?
Yeah, so when the rock from space comes down to our atmosphere, has it ever happened where it like broke apart, or does it always stay together?
They do both. And I think I liked the video because it talked, you saw that 1908 event, and they really think that there was no impact crater. It was just like a bunch of downed trees. And when I say bunch, I mean like scary a lot.
Yeah, it sounds like millions of square miles.
Mm-hmm. And I think that one is kind of what you're saying. They think that basically it broke up and then it kind of just rained down meteorites. Okay, rained down little meteorites. Was that what you were saying?
Yeah.
Yeah, exactly.
I was just curious.
But like the, and I don't know if you saw in the video, let's see, Winslow, Arizona, it's got that big crater, okay?
Yeah.
That probably was something that maybe stayed intact, and it gave us that impact crater.
So what distinguishes between the two, like how do you know that one's going to break apart?
Well, and that's where the dude who talked a lot about Jupiter and kind of that, you need to know kind of the composition of the rock, and it's hard to know because you don't know like its composition and how firm it is, or if it's got fractures that are gonna, it's kind of a mixed bag. And actually that kind of gets to this. These are space rocks, and there are two types of space rocks. Remember, meteorite is, I guess, should I call it a space rock? Meteorite is a rock that you can touch, a space rock you can touch, yeah. Okay, so there's primitive and processed, and those would give you kind of different sort of phenomenon as they fall. All right. Oh, and then there's this, I don't know if you need this down here, it says, we have recovered meteorites that the chemistry matches up to the chemistry on the moon. We've recovered meteorites where the chemistry matches up to the chemistry on Mars. Martian meteorites? Like, are you serious? Yeah. From Mars. Yeah, from Mars.
So that probably means something like hit Mars and project it out.
Yep.
So we didn't even have to leave Earth to get to Mars.
Right. And then did you see the video where they kind of, with all the snow and that little black rock? Okay, so it's hard to find these, okay, but like where it's snow covered for long periods of time and people aren't disturbing it, actually that's a good place to go looking for these rocks.
To Antarctica.
Antarctica?
Yeah.
Road trip. Okay, so this actually, that little glowing orb in the center is the sun. The little blue line there is where Neptune is. So this video, or this figure is clear like this. So Neptune orbits the sun. And this figure is finally kind of showing you, starts letter K, what's this out here? Kuiper belt. Starts letter O, what's this? Oort cloud. So this figure is kind of showing you those two things. And we've been talking about how those have the icy, rocky objects. Those have our comets. Now, I'm gonna go out over here, okay, and I'm gonna be a comet, okay? And I don't know if I necessarily put this in the form of a question, but the answer is you don't know, these comets do not leave those tails. This comet will not leave a tail. Okay? This comet next to the sun will leave a tail. Why is that? Yeah, because the sun's heating it up. And kind of like that, the gal on the video showed, I thought that was so cool how she kind of made the comet and held up to a light bulb and it just kind of fits like that. Yeah, exactly. So we kind of have that thing going on.
I have-
Yes.
As the comet comes in around the sun and it gets close, we start to see its trail.
Right, exactly.
As it gets around the sun and comes the other way, does it lose its trail?
Right, exactly, because it loses its heat. Yeah, yeah. So the closer it gets, the longer the tail. And as we call this perihelion, just like we call as a planet's closest to the sun perihelion. This is also perihelion. So it reaches perihelion, it's going to have the most fizzing it's going to have, and then as it goes out there, it's going to get colder. Yeah, it's going to stop fizzing. Yep. So one of the things I'm going to do, hopefully a little bit of homework before Friday, is to try to see how that comet Johnson. I'm thinking the first part of April is the best time to try to see its fizziness because it's kind of how close is it to the sun and kind of how close is it to the earth. Very good. So comets become visible. Now, aren't these beautiful? Okay. And each comet has its own personality. You're like, well, what does a comet look like? Well, for me, actually, like I said, I'm going to do some homework. I'll just like Google Comet Johnson images. And I'll be looking for what that comet's supposed to look like, because they all are a little bit different. Let's see, comets, blah, blah, blah. The third thing is kind of cool. They call them kamikaze comets, is what I've heard them called. There are comets that actually, just because of, they come out from here, and they get close to the sun, they start fizzing, okay? And some of them actually, because of their trajectory and the gravity of the sun, they fall into the sun. So, kamikaze comets. Well, I think this is a good place to start, and so we'll just see how far we get on Friday, but we'll definitely finish this on Friday and probably start the next chapter. And if you jot down that heavens-above.com, actually that's what I'm going to start with. That is a great website. heaven-above.com. If you are thinking about trying to see a comet, that's where I would go. heaven-above and then .com.
Okay, I have a quick question for you.
Yes.
On the